So here's that next one. I don't know that there was as much problem with this one as the one before, but this one can be a hard one. Suppose, again, that we've got this Chinese producer that can sell to both ISIS and Syria, no worry about resale. What the nuance here is that now marginal cost depends on the quantity produced, Q, which is the combination of the Q, the quantity sold to ISIS and the quantity sold to Syria. And so how do you do this? It can be challenging once you realize how to set it up, though. It's not too bad, or usually you want to graph these problems and use that to guide you. In this case, the graph is sort of a pain, but the algebra is pretty easy. So that's, if you see something like this, and again, the key feature is that marginal cost is increasing with output. That means, whoa, this we can do this algebraically, but don't bother with the graph. All right, so we had those same demand curves as I had before. Let's proceed. So how to proceed? Well, let's call ISIS market 1, and I'm going to get the inverse demand curves. Just take their demand curve and put it in terms of P instead of Q. P1 equals 1,000 minus Q1. So the key here is I'm not just calling this Q, I'm calling it Q1. I'm going to have Q1 and Q2 floating around here. Marginal revenue in the ISIS market that I've just arbitrarily called market 1 is 1,000 minus 2Q1. We do the same for the Syrian market, and we get P2 equals 4,000 minus 2Q2, and then marginal revenue function in that market is equal to 4,000 minus 4Q2. All right, and now what do we do? Well, we remember that, we remember that our marginal cost is equal to the sum of those outputs, Q1 plus Q2, and thus we know that marginal cost is equal to marginal revenue in market 1 and in market 2. So that gives us two equations that we can express in terms of just two unknowns. So Q1 plus Q2 is equal to 1,000 minus 2Q1, and also Q1 plus Q2 is equal to 4,000 minus 4Q2. So there we have it, two equations, two unknowns. There are several ways to solve this. Let's put these both, let's just move them. Let's convert these so we just have Q1 and Q2 on the left-hand side, and then just have numbers on the right-hand side. So 3, adding 2Q1 to both sides, 3Q1 plus Q2 equals 1,000. And then we do the same for the next equation. We're going to add 4Q to both sides, 4Q2 to both sides, sorry, and we get Q1 plus 5Q2 equals 4,000. So I just wanted to get this into a form where I could just eliminate one of the two Q1s or Q2s. I could either multiply that. Actually, why don't I just do that? I'll multiply this top expression by negative 5Q2, right? It's same difference. And realize I haven't worked these numbers out to be nice and pretty, so I'm going to get some not round number. So again, I'm going to multiply this top expression by negative 5. And that what I'll get is negative 15 Q1 minus 5 Q2 equals negative 15, sorry, negative 5,000. All right, so then I'm going to just, how do I do this to, let me change colors. I'm just going to cross this one out because I've got it up here in an equivalent form. So now I can just add this beast to this beast, and I'll just be left with one expression in terms of Q1. All right, so the negative 5 Q2 plus positive 5 Q2, that drops out. Negative 5,000 plus 4,000, I get negative 1,000. And I get negative 15 Q1 plus positive Q1 is negative 14 Q1. So Q1 is equal to, I'm multiplying by negative 1 over 14. Q1 is equal to 1,000 divided by 14. And of course that is, it isn't some pretty round number. I think it's 71.43. I'm just going to write it down, 71. And then Q2, I can plug that 71 into either one of these expressions and solve for Q2. And again, I'm going to have to round, but well, I will have rounded. What you get there is Q2 equals 786. And then to get the prices, of course, I can just plug these quantities. I can plug this quantity in ICIS into the demand for ICIS, and I get P1 is 929. And here I do the same into the Syria. P2 equals 2428. So there we have it, that algebraic solution. You know, there's a lot of steps, but remember, we're just following our marginal cost equals marginal revenue step all the way through.